Okay, and once again, we're going to take another crack at this. I think we're good. Double check the microphone. So hopefully this is picking up everything I'm saying. All right. So in this video, I'm going to be talking about organizing and visualizing variables. All right. So a couple things we're going to talk about. There's methods to both organize and visualize variables. There's also methods to organize and visualize more than one variable at the same time. And then we're also going to talk a little bit about some of the techniques and approaches we want to take when we're doing visualizations, because visualizations are very powerful. It's a very powerful part of the analysis. However, you want to make sure that there's certain guidelines you want to think about, because really it's a form of communication. So understanding kind of what your audience is and what's the most effective way to communicate with them. All right, so we'll start with categorical data. Remember, we have categorical and numerical. So categorical data, we're going to start with looking at scenario where we have one categorical variable. All right, and we're going to use a tool called a summary table. And then when we have more than one variables, more than one categorical variables, we're going to use another tool which we're going to call a contingency table. All right, so the summary table, we've seen these quite a bit. It's also the summary table, also called frequency table. What we do is we take the percentages, or the frequencies. Frequencies really are the percentage that one response has of the total. All right. So in this case here, what we have is better prices are 370, which represent 37% of the total. Or all these together will add up to 100%. All right, avoiding holidays and castles with hassles, 290, so on and so forth. Okay, so this is just simply we take our categorical data, we take the results of our categorical data, and we just simply tally it up by bucket. Okay. Now, what happens is that's the case for a single, so that's pretty straightforward. Where we have more than one variable, we can use something we call a contingency table. All right, a little bit of a different tool here. All right, so what will happen is, and what we'll use this for, we have the patterns that exist between responses of maybe two or actually more categorical variables. All right, so what we do is we cross-tabulate or tallies the jointly responses of the categorical variables. All right, and the way we do this is, we separate it into the one categories of the categorical variable are represented on the columns, and then the other one is represented on the rows. All right, so this is also called a crosstab or cross-tabulation. So to give you an example here, once again, this is a contingency table for categorical data. All right. And so our scenario here is we have 400 invoices drawn, and each invoice is really categorized two ways. All right. One way is whether it's a small, medium, or large invoice. All right. So we'll have some sort of gradation dividing up how many are in each class, and then we'll also do identify if there's any errors. All right, so there's two variables, and what happens is where they intersect is where we put our numbers at. So what will happen is, in this case right here, no errors and a small amount is 170. All right, errors and a small amount is 20. So combined, it's 190. All right, and we do horizontal and vertical calculations. So ultimately in our lower corner here, this is our total. Everything should add up to the total. Now what we can do after we do that, after we kind of move things into the individual buckets, we can come back in and we can do another form of analysis, okay, where we can actually convert for every cell count. We can convert that. We can run a calculation on it where that cell count is calculated. So there's three percentages we're going to generate. One is going to be the total percentage, which is made up of the cell count versus the total count. Right. The row percentage, which is made up of the cell count versus the row count. And then the column percentage, which this is the cell count versus the column count. All right, so what we see here, we have our total count here. This is our column count, column counts, one for each column. Here's our row counts. We have three of them, one for each row. All right, so what we'll do is we'll take, say for example right here, we'll do this as a calculation. Small amount, no errors. All right. We'll do for the first number, for the first set, which is the total, which says 42.5% of sampled invoices have no errors and of a small amount. Also, 89.47% of the small invoices have no errors. And finally, the third percentage is 50.75% of the invoices are no errors. 50.75% of invoices with no errors are also of a small amount. All right, so we can do this calculation, and we do this calculation for each cell. All right. So there's a concept we call a profile. All right, so the profile is where we combine a whole bunch of different attributes, or represented by variables, for something. So in case, like in one case, this could be for an individual under study. All right, so we take a bunch of different characteristic data variables, each one representing a different characteristics, and we do the individual calculations, and then we combine them together to create what we call a profile. All right, so in this case, we can use an example of what is typical. All right. And we assemble them all together, and then it creates for us a composite picture. All right, so we're going to take a look at our one of our cases. Undergraduate student, profile of an undergraduate student represented in the survey. Student has made a decision about graduate school and is open-minded about taking a course in statistics. So we can take this, we can derive that from basically doing the individual calculations for each one, and then being able to say being able to, with that calculation, be able to say that is the results. And then we can also, do alternatives. The same kind of the same process. We do it for every variable. All right. So it's male, female, graduate school, statistics. Are three variables we have that describe, three of the variables that help to describe. An individual. It's once again, it's in there. The profile is made of the composite of all of these different attributes. All right, so this is the most typical person was what we did in class, basically the National Geographic exercise. All right. All right, so that was all that we just talked about was really focused on numerical data. All right, now we're going to talk about, everything we had talked about before, scratch that. Everything we talked about before was categorical data. Now we're going to talk about what we do to organize numerical data. All right, so there are 3 approaches to numerical data. Let's look at each one. So the first one is something we call an ordered array. Right? And all that is we take our set and we sort it in sequence. We sort it into high-low sequence from the smallest to the largest. What it does is it gives us a couple bits of information. Number one, it will tell us what the range is. For example, 16 to 42 for day students, 18 to 45 for night students. And it can also might help us where we have situations where we have outliers or unusual observations. A couple things can cause outliers. One is it's a legitimate outsider. It's a legitimate outlier. So, and those we want to go back and maybe explore what is making that up. The other possibility is just bad data. All right. So you really want to kind of determine that. And, if it's bad data, then maybe you want to go back and do some more cleaning. All right. And kind of filter out things that would be in ranges that would not represent if we know that if we can determine that. All right, so that's all this is. That's all the ordered array is. We simply take all of our values and we sort them into rank order. Right. The second approach we do is something we call a frequency distribution. So frequency distribution is a summary table in which data is organized into numerically ordered classes. So what we're actually going to do is break things into different classes at different ranges. All right, so the things we're concerned about in these is making sure that we can define the width of the grouping and what the boundary is. All right, because the thing we don't want to do is we do not want to have an overlap. All right, because then potentially you get to a situation where you come up with you have a value and which one does it go into. All right, so the idea is all of these groupings are mutually exclusive. All right, how the number of classes we create depends on the data. All right, larger numbers of values, we can have more classes. But generally, what we're looking at is to have at least 5 and no more than 15. Right? So that's a general rule of thumb. Right. And to figure out the width, what we do is we figure out the range, as we talked about before, the highest value minus the lowest value by the number of class groupings desired. And what that will do is that will give us a distribution that we can work with. All right, so let's take an example here. All right, manufacturer of insulation randomly selects 20 winter days and records the daily high temperature. All right, so that is 20 days during. So the population is all the days of winter running from the beginning of, right before Christmas, I think it's the 23rd of December, through March. All right, and we picked 20 of those days and we recorded the high temperature. All right. Then we sort it into order. We sort it into our, our high-low sequence. All right. So this is, our range would be 58 minus 12. All right. And that gives us what the range would be of the data that's in our array. All right. And then what we'll do is we will come back in and just simply take each number and count where it fits. All right. Ultimately, we put it in the appropriate box or bucket, and at the end, we will, be able to tally up the frequency. All right, so within the sample, we have 3 recordings that are at least 10 but less than 20. We have 6 that are at least 20 but less than 30, which is 20 to 29. All right, so the thing you always want to watch this is make sure we're using less than, and we're making sure that what the number we're using is excluded. So 20 is equal to 20. 19 is less than 20. So this range is actually 10 to 19. All right. And then we tally everything up. That gives our starting point for the frequency distribution. Then once we have that, we can then go through a couple of additional calculations. All right, where we can calculate what we call the relative frequency. And all the relative frequency is the number that we captured in our frequency divided by the total. So it's the percentage of each one. So 15.15 represents the number of values that we found that were at least 10 but less than 20. All right, and the 0.15 translates into a percentage. So basically, 15%, 30%, 25%. Everything adds up to 1 or 100. All right, so you always want to make sure all the numbers everything adds up to 100 at the end. All right, so that gives us so this relative frequency is kind of is a first cut at a calculation. And then we can go through and we can calculate the cumulative percentage, which is the cumulative frequency, all right, divided by the total times 100. All right, so that what that is going to be 100 times 9 divided by 20. All right. And we just simply do that for all of our, all of our individual values here. We're basically building out the table. All right. So those are so basically what they are. What we're looking at here is just some simple ways of taking a set of data, taking a set of samples, and organizing it in some way to be able to give us a representation. Now, once we create these models, so ultimately what we're creating is we're creating these tables. All right, so we're taking, we're basically setting this up, organizing it, establishing a framework, then counting the data, going through the data and figuring out where everything fits into what buckets. All right. So the next part we want to look at is how do we represent this stuff? How do we, obviously we can look at these charts, which will tell us, and it actually, gives us some sense of the data, kind of the distribution of the data, the shape of the data. But what you really want to do is really try to look to visualize it, convert that data into some form of visualization. All right, and once again, we divide our approaches between what we do with categorical data versus what we do with numerical data. So for categorical data, we had our 2 scenarios. One is our summary table for one variable, and then we have a contingency table for 2 variables. All right, for a single value for the one variable, the summary table, what we can do is we can do a couple different standardized charts. So the ones that probably make the most sense for situations like that is either a bar chart or a pie chart, or a Pareto distribution. But usually, bar charts and pie charts are the 2. For a contingency table, so for 2 variables, 2 or more, what we would do is we would use a side-by-side bar chart. All right. Give you an example. All right. So the bar chart really takes our variable and we visualize it as a set of bars. Right? So we have our categories, and this is their categories, and this is the measurement of what we found. All right, and then this is our scale at the bottom. The percentage is the scale. All right. So by looking at this, we can look at this and say, when we ask the question is why, what's people's reasons for shopping online? It's better prices. All right. Ships directly is not as impactful. All right. And then, the question of better prices versus avoiding crowds. All right. Avoiding crowds is number 2. All right. But we can tell that, we can get, we can see it here, but if we sort that, but we can really visualize it here. Okay. And here's a pie chart. So the pie chart really represents the same thing. This chart represents the exact same thing as that chart. Okay, it's just a different picture. Okay, so what we have is, and actually this one does, I don't think this one does quite a good a job. All right, because if we look at the better prices, which is 37%, and we match it up against the avoiding holiday crowds at 29%, at glance, it's hard to, those are the major ones, but which one is actually bigger? You put the percentage on it, so that'll tell you. All right. There's other cases where the pie chart is the better visualization to go with. So it's really, you kind of, what we're looking to do is effectively communicate. So you have to think about your audience. 2 things. You want to think about your audience, and you think about what you want to tell your audience. What's your message? All right. And then the other thing where we have more than one categorical variable, we can create a side-by-side chart. All right, where what we're doing is we've done this calculation, we've done all of our calculations here, and we can represent it, as errors and no errors, matched up against our percentage on the horizontal. All right, so the errors and versus no errors is our vertical axis, our y-axis. Our x-axis is the percentage of each one. All right, so we say invoices with errors. If we look at the chart, our visualization here, we can say invoices with errors are much more likely to be of medium size. So it's 61.54 versus 30.77 versus 7.69. All right, so it's very simple calculations. So we're taking data, and like I said, the main thing we're doing is we're establishing a framework. Taking our data, getting some understanding of what it looks like, creating a structure, populating the structure, and then visualizing the structure. That is the essence of what DCOVA means. And here's what we're going to do from numerical data. All right, so we have numerical data, we have our ordered array. So all that is just our data sorted into an order. And the recommendation is to use a stem and leaf display for our chart. I've never used a stem and leaf display for a chart. All right, just in truth in advertising, I've never used one. All right, but I mean there may be circumstances where that would come into play. I have used frequency distributions and cumulative distributions, and used histograms and polygons. All right. So just an example of stem and leaf. So we separate the sorted data series into the stems, leading digits, and the trailing digits. All right. So we've then kind of created we've kind of created the data, we've kind of created a set of groups. and organize the values within each group. So once we can do that, there's other things we can use with that. So there's a bunch of other different tools that we can use to represent and visualize this stuff. So frequency distribution tables, histograms, box and whisker plots. Bell-shaped symmetric, skewed left and right, uniform bimodal. So there's a whole bunch of different charts we can use to be able to do this stuff. All right. Now this is going to be probably more. This is going to be a much more common. So the histogram. So the histogram is a vertical bar chart and a frequency distribution. It's called a histogram. So what we saw here, that's a horizontal bar chart. Okay. This is a vertical bar chart, aka what we call a histogram. All right. So in a histogram, there's no gaps between the adjacent bars, so everything is contingent. One's right next to the other. The boundaries, the class boundaries, where our separation points are, the break points, they're on the horizontal axis. And then the vertical axis is we use frequency, relative frequency, or percentage. All right. And then the height of all the bars represent the frequency, relative frequency, and the percentage, like we said. Kind of a picture of this. So as we say, this is our kind of our breakpoints here. All right, at the bottom. These represent the counts, and the relative frequency. So we measure this against the chart. And we can do a different one based upon percentages and but the same basic mechanics. Then we have a percentage polygon. All right, so this is a little bit more advanced. All right, having the midpoint of each class represent the data in that class, and then connecting the sequence of midpoints. So the idea is what it is. It's a chart. Basically, it's a charting mechanism. So we go to the midpoint of every class, and what we'll do is we'll connect them together. So we're going to draw a line between multiple charts. All right, we'll try a, what we'll do is we'll compare two sets of data, comparing two groups of data. We'll create the curve for the one. So these are connecting the midpoints. So we plot the points, we draw a line to connect them together. And if we're doing two variables, we're measuring against two different types of different types of results. We can see a comparison of one versus the other. So two numerical variables. Couple different ways to do this. One we call a scatter plot, and the other one is called a time series plot. All right. So the scatter plot is we take the x. So there's with two variables, we have two data points. All right, or two variables, which if you plot it on a grid, represents a particular spot on that grid. All right, so we take a pair of observations. We take the two numerical variables that we have, and then we combine them together, and then we plot that point on a chart. So one's measured on the vertical axis, one's on the horizontal axis. And what it gives us is a visualization of the relationship, of any possible relationships between the two variables. All right. So in this case here, a scatter diagram is, we have volume per day, cost per day. All right. So on our x-axis, we're going to put volume per day. in our vertical axis, we're going to do cost per day. All right. And then as we plot, we see the shape of a curve as we move along. All right. That's a scatter plot. Now, what happens is if we take that sort of analysis and replace the x-axis, the bottom axis, with time, that gives us a time series plot. All right. So what it does is it gives us the pattern of a variable over time. All right. So the vertical axis measures basically the value, and the time periods is on the horizontal. So in that case, what we have is a time range running from 94 to 2006. That's the time. And then we plot the individual points. 96, 97, 98, so on and so forth. Once again, this also gives us in this case, because we have years, this is the timeline over years, time series of data. All right, so we're always going to, so we can see at different points of time what these values are and kind of what direction things are moving in. All right, so just a couple final points to wrap up here. So, what you want to do is the guidance that they're providing is really that we want to use the simplest possible visualizations. I mean, the thing is we can have you can create all sorts of crazy visualizations. It's not super difficult because tools are very capable these days. But think of what we're trying to do. We're trying to communicate to an audience. So you really want to keep the audience in mind and try to keep it, the KISS principle. Keep it simple, stupid. All right. You want to include a title, and you also want to label all of the axes. All right, because what will happen is if you don't, what somebody's going to look for is number one, they want to kind of know what the title is, so you set the context. All right, and then the individual axes will tell us kind of what you're comparing what to what. All right, and then if there's a scale, like miles or feet or inches or whatever, or time, we won't put it. We want to include. You usually want to include a scale. All right, and typically, if we're doing a vertical axis, the scale for the vertical axis will start at 0. All right. You want to use a constant scale. All right. You want to avoid 3D effects. All right. You can use them. I think once again, I think it's a judgment call. Under what circumstances would you use a 3D effect versus, because what happens is if you make these things too exotic, then you kind of lose the message of what you're trying to communicate. So you always have to think about what you're going to communicate. And then finally, avoid chart junk. Right. So which is, all the stuff we can, all the stuff people can throw out there. The more fruit salad you put onto your chart, you run the risk of distracting people from what the core message is. So that's, I think, why the emphasis on simple, direct, clear communication. All right. Now, just some other stuff. And we're not actually covering this in the course, but we do cover it in CSC 155, all right, which is the computer science course for business majors. And what it is, it uses what we call pivot tables. All right, so a pivot table is a tool which is actually built into Excel that enables us to, summarize variables across different dimensions. All right, and we can dynamically, as we're sitting there, we can change, the levels of summarization and the formatting of the variables. So we can kind of drag an axis from one side to the other, and the chart will dynamically rebuild itself to give you the new perspective. All right. You can also do things like you can also slice your data. So what you do is you can select out pieces of the data to shrink things down. So it's a very powerful tool. It takes a little bit of practice to get really good at it. All right, but once you're good at it, you really can, you can get a real, you know, insight into kind of what's going on with different circumstances. All right, so the idea is you can use, you can create create a model, and then you basically give it to the user, and the user can then decide, what variables and which way you want to view it by using filtering. All right. So using slicers is just simply a form of filtering. So what you want to do is you only want to, you want to do a subset of the data. So filtering, reduction is one of the key techniques we use when dealing with data. The idea of reducing data, consolidating data, summarizing data. All right. Slicers can be used to filter any variable, and you can actually make it look pretty slick. You can actually make it look like it's a sophisticated program. When it's kind of using the tools, basically the tools that are built into Excel. So as I said, we don't cover it here in our class, but it is covered in CSE 155. All right, and that wraps this up.